UTman600. How to draw in-service defects. First of all, in UTman we can see we're initially testing a pipe weld, and the green area shown here is a 60-degree probe. We could change that to a 70 with blue, or 45, or 0. I'll leave it on 60 degree. So this view is the 3D view of a pipe weld. I'll shrink that one down. Now the lower rectangle here is a cross section through the weld. So that's a cross section through the circumferential pipe weld. The upper rectangle shown here is a plan view looking down upon that same circumferential pipe weld. The 3D image just helps us to visualize it. We've got a choice of multiple UT sets. For the purposes of this exercise, I'll leave it on the Olympus Epoch 600. Now, to draw in service defects, we can click on the defects button, and then we can select defect 1 and draw, for example, in the root something like that, and then make it a small size, and then select defect 2. We'll make that slightly different location, and we'll make these alongside each other, and then we'll have the separation of these defects as being 2, and the length of all of these defects being 2 also. So defects, I've already created 2 very small reflectors, each 2 millimeters long. I'll create a third one now. I'll place the defect something like this, and place it alongside the other 2, and I'll create a 4th one. Perhaps put it here, and a 5th one. So what we've got is we've got a total of 5 drawn defects, which now, because each one is a different reflector shape and has different reflection properties, we can get a simulation of an in-service root corrosion. Here we can see a good root image here. We come down to the root erosion, and we can see a change, a shortening in the beam path distance. So this could be plotted out on the plotter, and that would be plotted out to approximately here on the plotter, indicating it's coming up before the root and has a short time of flight relative to a good root response. Now for other defects, we could, for corrosion, I'll delete all of these, delete all. We could say we could have defects which are within the pipe wall. I'll move the defect area over. We could have an area like that there. And I'll make the length of these separation 9 and length 5. Now defects, so now we'll select the first one, which has been drawn as shown here. The next one, again, we'll move it over, and we'll draw a corroded area like that, and we can move that one over here, and then we could have a third one. Obviously we could put 2 or 3 in the same location. I'll put that one here. Now if we now scan that with the 0 probe, and I'll change the range. So now I've changed to a 0 degree probe, and the range on the UT set I've set to 50 millimeters. This is a 20 millimeter pipe wall thickness. So the first back wall echo on a good section of pipe is at 20 millimeters. This is a 50 mil range, so it'll say 40 and 80 for the second back wall echo. So this represents 20 and of course 40 for the second back wall echo. So we're looking at the first back wall echo, which represents 20 millimeters, and we're getting a good back wall echo. It's non-varying. We hit our first area of pitting, internal pitting, as an in-service defect, and we can see this the echo is coming up early, and I'll move the gate. So I've now moved the gate into the position, so it's capturing the 20 millimeter distance back wall echo. We'll now go over a pitting area on the internal surface, and you can see on the UTman600 reading it's giving us a depth of 17.5, so we've lost 2.5 millimeters of wall thickness, as you can see in the cross section. We go to the second area. There's the good back wall. We're moving into the pitted area, and we're getting a change in back wall shape, and we're getting an echo there of 16.5, a 3.5 millimeter loss of wall thickness. The third area here, we're getting 15.5. There's a 4.5 millimeter loss of area of wall thickness. And here on the last shape we've put in, we're getting 17 millimeters, which is a loss of 3 millimeters of wall thickness. Now these in-service pitting defects on the internal surface could be spread out more or put more densely, and we can also hide them, give them a password, and now they're still there, but you can't see them. You can only detect them with ultrasonics. There's our first one. We can see coming up on the A scan now. You can see it here. Then I think we've got another one about here. We can see it here. There's a third one there. And there's a fourth there coming up. 17 millimeter wall thickness, a loss of 3 mil on the 20 millimeter wall thickness pipe. We can unhide the defects to see where we are. So this is very handy for testing people's ability to see if they can actually calibrate properly and find in-service defects, either in the weld or indeed in the parent plate material. That concludes the video on in-service defects.